Hey, what's up everyone? Today we're diving into some physics MCQs, so grab your notes and let's get started. Question 1. 85.95 degrees in terms of radians is A. 1/2 radian, B. 1 radian, C. 1 1/2 radian, D. 2 radians. Pause the video and think about your answer. The answer is C. 1 1/2 radian. Explanation. To convert degrees to radians, 180 degree is equal to pi rad. We get the formula. Radians equal degrees multiplied by pi divided by 180. Plugging in 85.95 degrees gives approximately 1.5 radians, which can be expressed as 1 1/2 radian. Question 2. What is the circumference of a circle with a radius of 50 centimeters? A. 3.12 meters, B. 3.14 meters, C. 3.16 meters, D. 3.18 meters. Pause the video and guess the correct answer. The answer is B. 3.14 meters. Explanation. The circumference of a circle is given by 2 times pi times the radius. Using 50 centimeters, which centi equal to 10 power minus 2 gives approximately 3.14 meters. Question 3. What is the angular velocity of a particle when its frequency is 50 Hz? A. 312 radians per second. B. 313 radians per second. C. 314 radians per second. D. 315 radians per second. Pause the video and think about your answer. The answer is C. 314 radians per second. Explanation. Angular velocity is calculated as 2 times pi times the frequency. So 2 times pi times 50 Hz is approximately 314 radians per second. Question 4. The direction of angular velocity is along A. Tangent to the circular path, B. Axis of rotation, C. Inward the radius, D. Outward the radius. Pause the video and guess the correct answer. The answer is B. Axis of rotation. Explanation. Angular velocity points along the axis of rotation and follows the right-hand rule. Question 5. Angular speed for the annual rotation of Earth in radians per day is A. Pi divided by 2 radians per day, B. Pi radians per day. 2 pi radians per day, D. 365 radians per day. Pause the video and think. The answer is C. 2 pi radians per day. Explanation. The Earth makes one full rotation, which is 2 pi radians, around the Sun each year. Dividing 2 pi by 365 days gives the daily angular speed. Question 6. A body moving with constant angular velocity on a circle has an angular acceleration of A. Radius times angular velocity squared, B. Constant c 0, D. Radius times angular velocity. Pause the video and guess. The answer is C 0. Explanation. If a body has constant angular velocity, there is no change in rotational speed, so angular acceleration is 0. Question 7. The banking angle of a road does not depend on A. Mass, B. Speed, C. Radius, D. Gravitational acceleration. Pause the video and think. The answer is A. Mass. Banking angle depends on speed, radius, and gravitational acceleration, but not on the mass of the object moving along the path. Question 8. What happens when the height of a satellite's orbit from the Earth's surface is increased? A. Speed increases, B. Angular velocity increases, C. Time period increases, D. Gravitational acceleration increases. Pause the video and guess the answer. The answer is C. Time period increases. Explanation. When the satellite's orbit height increases, the path it travels becomes larger, which results in a longer time period. Question 9. What should be the ratio of translational and rotational kinetic energies of a solid sphere? A. 1/2, B. 2/3, C. 5:2, D. 2:5. Pause and think. The answer is C. 5:2. Explanation. The formula for translational kinetic energy is 1/2 of the mass times the velocity squared. The formula for rotational kinetic energy is 1/2 of the moment of inertia times the square of the angular velocity. For a solid sphere, the moment of inertia is 2/5 of the mass times the radius squared, and the angular velocity can be expressed as the velocity divided by the radius. Substitute the expression for the moment of inertia and angular velocity into the rotational kinetic energy formula. This simplifies to rotational kinetic energy being 1/5 of the mass times the velocity squared. To find the ratio, divide the translational kinetic energy by the rotational kinetic energy. Simplify this ratio by canceling out any common terms. The result is that the ratio of translational kinetic energy to rotational kinetic energy is 5:2. Question 10. Angular momentum in terms of moment of inertia is A. Moment of inertia times angular velocity. B. Moment of inertia times angular velocity squared. C. Moment of inertia squared times angular velocity. D. 1 divided by angular velocity squared. Pause the video and think. The answer is A. Moment of inertia times angular velocity. Explanation. Angular momentum is the product of the moment of inertia and the angular velocity. Question 11. Which of the following rolling bodies has 50% translational kinetic energy and 50% rotational kinetic energy? A. Disk. B. Ring. C. Rod. D. Sphere. Pause and guess. The answer is D. Sphere. Explanation. A sphere rolling without slipping distributes its total kinetic energy equally between translational and rotational forms. Question 12. A solid cylinder of mass 20 kilograms rotates about its axis with an angular velocity of 10 meters per second and radius of 0.2 meters. The moment of inertia of the cylinder is A. 0.2 kilogram meters squared, B. 0.4 kilogram meters squared, C. 0.6 kilogram meters squared, D. 0.8 kilogram meters squared. Pause the video and think. The answer is B. 0.4 kilogram meters squared. Explanation. The moment of inertia for a solid cylinder rotating about its axis is given by 1/2 times the mass times the radius squared. Now putting the value, we get 0.4 kilogram meters squared. Question 13. The condition of weightlessness is A. Normal reaction is greater than weight. B. Normal reaction is less than weight. C. Normal reaction equals weight. D. Normal reaction equals 0. Pause the video and think. The answer is D. Normal reaction equals 0. Explanation. Weightlessness occurs when the normal reaction force is 0, indicating there is no contact force acting on the object. Question 14. A sphere rolling without slipping on a horizontal plane has a rotational kinetic energy to translational kinetic energy ratio of A 2:3, B 2:5, C 2:7, D 2:9. Pause and guess. The answer is B 2:5. Explanation. The formula for translational kinetic energy is 1/2 of the mass times the velocity squared. The formula for rotational kinetic energy is 1/2 of the moment of inertia times the square of the angular velocity. For a solid sphere, the moment of inertia is 2/5 of the mass times the radius squared. The angular velocity can be expressed as the velocity divided by the radius. Substitute the expressions for the moment of inertia and angular velocity into the rotational kinetic energy formula. This simplifies to rotational kinetic energy being 1/5 of the mass times the velocity squared. To find the ratio, divide the rotational kinetic energy by the translational kinetic energy. Simplify this ratio by canceling out any common terms. The result is that the ratio of rotational kinetic energy to translational kinetic energy is 2:5. So the final answer is that the ratio of rotational kinetic energy to translational kinetic energy for a solid sphere is 2:5. Question 15. The frequency of artificial gravity is A. 2 pi times the square root of gravity divided by radius. B. 2 pi times the square root of radius divided by gravity. C. 1 divided by 2 pi times the square root of radius divided by gravity. D. 1 divided by 2 pi times the square root of gravity divided by radius. Pause and think. The answer is D. 1 divided by 2 pi times the square root of gravity divided by radius. Explanation. This formula is used to calculate the frequency needed to create artificial gravity in a rotating space station. Question 16. A particle of mass 100 grams starts its motion from rest along a circular path with a radius of 10 centimeters. If its velocity becomes 10 meters per second, what is the centripetal force? A. 0.1 Newton, B. 1 Newton, C. 10 Newton, D. 100 Newton. Pause the video and think. The answer is D. 100 newtons. Explanation. Centripetal force is given by mass times velocity squared divided by the radius. Here, mass should be converted to kilograms, 100 times 10 power minus 3 kilograms, and the radius should be in meters. Plug in the value of centi is 10 power minus 2 the values to get the centripetal force as 100 newtons. Question 17. Which one of the following is conserved when the torque acting on a system is 0? A. Kinetic energy. B. Angular momentum. C. Rotational kinetic energy. D. Linear momentum. Pause and think. The answer is B. Angular momentum. Explanation. When there is no external torque acting on a system, angular momentum remains conserved. This is known as the principle of conservation of angular momentum. Question 18. The orbital velocity of Earth's satellite near the surface is 7 kilometers per second. When the radius of the orbit is 4 times that of Earth's radius, what is the orbital velocity in that orbit? A. 3.5 kilometer per second. B. 7 kilometer per second. C. 7 times the square root of 2 kilometers per second. D. 14 kilometer per second. Pause and think. The answer is A. 3.5 kilometers per second. Explanation. Orbital velocity is inversely proportional to the square root of the orbital radius. If the radius increases by a factor of 4, the velocity is divided by 2, making it 3.5 kilometers per second. Question 19. When a parachutist is moving downward with uniform motion, then its weight is A. Decreasing, B. Increasing, C. Remains the same, D. 0. Pause and think. The answer is C. Remains the same. Explanation. The weight of an object, defined as the force due to gravity acting on its mass, remains constant regardless of the motion. Uniform motion means there is no net acceleration affecting weight. Question 20. An object of mass 1.5 kilograms is suspended by a string with tension 5 newtons in an elevator. When the elevator is moving upward with an acceleration of 2 meters per second squared, what is its apparent weight? A. 8 newton, B. 5 newton, C. 2 newton, 1.5 newton. Pause the video and think. The answer is C. 2 newtons. Explanation. The apparent weight can be calculated by adding the product of mass and acceleration to the tension in the string. Here, the formula is tension minus the product of mass times acceleration. Plugging the value, we get 2 newton. Feel free to review these questions and answers for further understanding.